Use the differential equation to create a slope field. So a problem like this could take a very long time and show a lot of work, so I'm going to try to do this somewhat quickly. But the way you handle this is you have, wow, is this 25 points? So this is going to take a few minutes. You have 25 points here, and you choose one of the points. And let me show you that algebraically, and maybe from there we can do a little bit of mental math. So let me pick this point right here. Okay, dy dx means the derivative. The derivative means slope. That point right there is the point -2, +2. Okay, -2 is an x value, +2 is a y value. So to find the slope at that point, we replace x with -2 and y with +2. And that gives us -4. And the slope of -4 is going to look like a steep negative line. So what a slope field looks like is we just take turns plugging in points into the differential equation to see what we get. Okay, so let's try it again with one more point. Let's try this point right here, which is going to be -2, +1. Okay, so -2 is my x, +1 is my y. So dy dx, the slope, is going to be replacing -2 with x, or vice versa, and replacing y with 1, and that gives us -2, which is a less steep negative line. And then we just keep doing this. Now here's the nice thing. This is where life is going to get pretty easy. Okay, a little bit. Everything along the x-axis has a y value of 0. And if I were to multiply anything by 0, I get 0. So all of these are going to be a flat line that looks like this. Similarly, everything along the y-axis has an x value of 0. So you're also going to get these flat lines like so. So now instead of having to worry about 25 of them, I only have to worry about 16 of them. Isn't that great? Let's keep this thing going. Basically, the rest of these, and let me get a different marker. The rest of these are just going to be me taking the points and multiplying them together. Okay, -2 times -1 is going to be a +2, so a pretty steep slope, positive direction. -2 times -2 is +4, so a steeper slope that's positive looks like this. Okay, let's come up here. -1 times 2 is going to be the same as that guy, -2, so a pretty steep slope. -1 times 1 is -1, so as diagonal can be. -1 times -1 is +1, so as diagonal can be. -1 times -2 is going to be +2, so something along that line. Okay, let's come up here. 1 times 2 is going to be 2. Pretty steep positive slope. 1 times 1 is going to be 1, so as diagonal can be. 2 times 2 is 4, so steeper positive slope. 2 times 1 is 2, so pretty steep positive slope. -1 times 1 down here is going to be as diagonal can be. 1 times -2 is going to be a pretty steep slope. -1 times 2 right here is going to be the same that we just drew out. And -2 times -2, +2 rather, is going to be a steep negative slope. So definitely not the prettiest picture that I've ever drawn, but you can kind of see how things spread out a little bit and kind of things, I don't know, flay out, if that even is a word. But yeah, that's how you draw a slope field. Never a fun thing to do, but not too difficult. Below is a slope field for which of the following differential equations. So we have this slope field going on right here. And whenever you're trying to match up a slope field with its differential equation, you want to look for either zeros first or zeros first. That's probably the best thing to do. I don't know why I said or there. Let's look for zeros first. So it seems to me that everything perfectly diagonally is going to give me my zero slope. which means like a -3 and a +3 will somehow turn into a 0, or a -2 and a +2 will somehow turn into a 0. So which of these would allow me to do that? Like if I were to test out -2 and +2, which one of these would allow me to do that? Well, A won't, because if I were to plug in -2, I get -1, so that won't work. If I were to plug in -2, I'd get 4, so that won't work. -2 and +2 would give me 0, so that's so far so good. How about if I were to plug in, let me see, -2, +2, that would be 1, so that won't work. Ln of y, so since I'm using +2, ln of 2 is a regular old number, so that one won't work either. So C is the only one that seems to make sense. And, if you had more than one option here after we tried out those numbers, then you would choose other numbers to plug in and see if they work. But this guy seems to do the job pretty nicely, so I'm sticking with C. The figure below shows the slope field for the differential equation dy dx equals x over 2y. Calculate the derivative at the point 3, 2 and verify that the results agree with the figure. All right, so this is my point. We'll label u x, we'll label u y. That's my differential equation dy dx equals x over 2y. Let's replace that x with 3. Let's replace that y with 2, so we get 3 over 2 times 2, which is 3/4. So we're looking at a positive slope a little bit more shallow than 1. So let's label, or let's find 3, 2. So here's 3, here's 2, and that guy seems to match up pretty nicely with that guy. So I'd say, yeah, sure, it works. Thanks for watching. Shown above is a slope field for which of the following differential equations. So we have this slope field here, we have a bunch of options here, and let's see what we can notice. What you should always try to do first is find out where your slope is 0. When y is 0, we have a slope of 0. When x is 1, we have a slope of 0 too. Okay, so let's do a little bit of mental math and see if we can eliminate anything. Okay, so at the point 1, 0, we should get 0. So you're an x, you're a y. Let's eliminate some stuff right there. Okay, so 1 times 0 is 0. 0 minus 1, I'm sorry, 0 minus 0 is 0, so A seems to check out so far. Okay, again, 1 times 0 is 0, plus 0. You seem to check out so far, so far we're not having good luck here. Until now, we have 1 minus 0 squared is going to be 1, so C is not an option because we don't get 0. We get 1 minus 0 inside the parentheses, which is 0, and 0 times anything is going to be 0, so you seem to check out, so D is still an option. And then E, we get 1 minus 1, which is 0, so yeah, you're still an option. So E, D, A, and B are still options, C is not. So now that we kind of eliminated one of them, let's see if we can eliminate any more. So we pick a random point, let's say U, because that looks like that gives us a slope of 1 right around there. That looks like a perfect 1 slope. That exists at the point 0, -1. So if I label u x and label u y, I'm expecting to get +1 when I do some math. Okay, so let's do some math. I always like to try to use zeros and stuff like that because it helps things go away when I run into problems like these. So if I'm going to plug it into here, I'm going to get 0 times -1, which is 0, minus sign. Y is -1, so a double -1 appears to be 1, so you check out so far. Okay. Similarly, 0 times -1 is 0, plus y is -1, gives us -1. I went +1, B is not going to work. If x is 0, I get 0 minus 1, which is -1, times y squared, which is -1 times +1, because -1 squared is going to be +1. You end up being -1, so D is not an option. And last but not least, if I plug in 0 here, I get 0 minus 1 cubed, which is negative 1 cubed, which is also negative 1. So E is not going to work. So A's got to be my guy. The frustrating thing about problems like these is you can test out other points and completely waste your time. Like you can look at some of these and like maybe plug in the point, I don't know, you could plug in the point 2, 1, because that looks like a 1 slope, and then maybe not get a result that you want. Fortunately, I picked that guy right there, and it seemed to give me the result that I wanted, and that result happens to be A, baby.